So my name is Naveen Chauhan, and in the last video I explained the connection establishment and various the, the problem issues with the connection management while we are selecting the TCP connection establishment phases. There were some simultaneous open, and then we discussed about the denial of services. Now in this second part of this video, I will explain the data transfer phases. So before the data transfer, we have already established a connection with the help of the three-way handshaking. Now in the data transfer phase, now both the parties are ready to, they already negotiated or they are synchronized their sequence number. So whatever the client will transmit, the server needs to acknowledge with the just +1 value of the sequence number. So after the connection of the establishment, bidirectional data transfer can take place. So in that, with the help of the single communication, now both the parties can transmit the data. And when we club the data with the acknowledgement, this particular scenario is called the piggybacking. So client and the server can both send the data and the acknowledgement. So now you can see on the first phase, now there is a sequence number 8000 once. If you recall the establishment phase, we have negotiated with the sequence number 8000. So in that time, the client initiated that I will transmit the data with the help of sequence number 8001. The reason is the sequence number 8000 was used for establishing a connection, and the acknowledgement 15001 is only sending for, so initially there were one, yes. So the third way of establishment connection, we sent the acknowledgement with 15001. Now again, we are just using the same field, and yeah, now you can see these 6 control fields. Out of these 6, 2 are set as 1. So 1 is your acknowledgement. So I'm just acknowledging the previous sequence we received from the server. So that's why this value should be 15001. Similarly, the push bit, it is only showing that. So push bit is setting as a 1 whenever you just receive a data. You do not need to wait for filling the window size. So whenever you get the data, just transmit it. So now you can see the data bytes are starting from 8001 to 9000. So it means all the bytes will take some sequence number. So it means I'm sending the sequence number from 8000 to 9000, right? So once it reaches to the server, then again I'm sending another segments. Now you can see, because both the segments have the push bit are set it as 1, so it is showing that. So whenever you have a data, it doesn't matter whether the size is lowest size. So whatever you are getting this data from the top layer, just transmit it. So I'm just sending this. So now you can see through the second segment, there is a sequence number is 9001. The reason is that we have already transmitted the data from 8001 to 9000. So sequence number will be 9000. Again, now you can see there the acknowledgement is 15001. So it representing that. So before the 15001, all are the sequence numbers are received successfully. But in that case, only the one sequence has been transmitted by the server to the client. Doesn't matter. Whenever you have a previous received sequence, just acknowledge it. So now you can see again, both the control fields A and P are set as 1, and the data is containing 9001 to 10,000. So it means I'm just sending the 1000 bytes. So whenever it is received to the server, now server will respond. So the acknowledgement should be the next value of the last received byte. So it should be 10,001. So then you can see the acknowledgement is 10,001. So now, and the requested, so acknowledgement is it's representing that what should be the next sequence. So it is the next expected sequence. That's why it is 15001. And it is sending some data. Now you can see it is sending some data, that is 2000, right? 15,001 to 17,000 of carrying the data. So once it reaches that, it will make that now the window size can be extended up to 10,000. So it will extend their sequence number. So now you can see the next sequence number. So there is no data for the client to transmit to the server. So it will only sending the acknowledgement bit. So the acknowledgement bit is acknowledging the last received sequence from the the last received byte from the server. So that's why it is 17,001. And what I transmitted before in the last segment transmission, it was 10,000. That's why the sequence number is a 10,000. So the pushing bit, the application program at the sending site can request a push operation. This means that the sending TCP must not wait for the window to be filled. So whenever it gets data, it will transmit it to the server side. Then there is another field, that is this, the urgent bit. So segment with the urgent bit can also be set up. So the urgent bit is very important, which defines that the TCP, that the piece of data is urgent. The sending TCP creates a segment and inserts a urgent data at the beginning of the segment. So it is like that. So let's suppose I'm transmitting some segment to the Google server. In between, the system feels that now I need to abort the transmission. So it will create a one finish procedure. But whatever. So what if I already transmitted? So I already created some of the segments which are putting in front of the queue. So these are ready to be transmitted to the Google server. Right. So in that case, if you want to immediately transmit or reset the connection, so you have to create a one segment with the urgent field setting as a 1. So in that case, the sending TCP creates a segment and inserts in the front of your front of all the segments. So that will be transmitted over the other segments. Then in this this video, this is the last the topic which I have to cover. So that is very important, the connection termination, because so far we have established a connection that we have seen in the last video. Now we have seen how we can transmit the data between the client and the server. Now the third phase, once all the two phases are done, now the third one, that is the connection termination. So any of the two parties involved in the exchanging data can start termination, can initiate the request of termination. Any of the party, the client or the server, can also, both. So although it is usually initiated by the client, normally it is initiated by the client, but it can also be possibly by the server also. So, but both the parties should send the finished segment until it will not be, the connection will not be terminated. So both the parties have to transmit the finished fin flag or fin command or fin control field. So there are the three, there are the two types of the version through which we disconnect the connection. The one is the three-way handshaking. It means with the help of the three ways or the three process, we can terminate the connection. And then we have a half close. For the sum of the duration, only the one side will be open and the another side will not respond, will not transmit actual data. It will respond, but it cannot send the actual data. So this is the three. So now you can see the client, it wants to disconnect the connection. So it will set the finish bit as 1. And let's suppose the previous sequence was the 1, and now the new acknowledgement is the 1. The new acknowledgement is the whatever the value. Let's suppose the previous value was the y minus 1. So the client is ready to transmit the fin command. So it will send it to the server. Now server will respond for this finish. So if it acknowledged it, as well as it also have to set the finish bit. It means the server is also ready to disconnect the connection. So whenever it receives at the client, so client will respond only for this finish bit. That's why now you can see they have set up a sequence X, acknowledgement Y plus 1. So the sequence will be acknowledgement will be the received one, that will be the X plus 1, and it was expected, so this will be pasted it here. Now there is no more sequence number here, so we were using the previous sequence, and the acknowledgement will be whatever I'm receiving. So sequence, the acknowledgement should be Y plus 1. Right, so this is showing the three-way handshaking procedure. So in a normal situation, the first phase is after receiving a close command from the client process, sends the first segment, that is the fin segment, in which the fin flag is set. Now the second phase can be when the server is also ready. So it will send the fin plus acknowledgement segment to confirm the receipt. Then the third phase, the client needs to just acknowledge the received fin segment, the receipt of the fin segment from the TCP server. There is the one another. So the segment contains the acknowledgement number, which is 1 plus the sequence. So it is very similar. Now this is the very important phase. So in that case, let's suppose the client is ready to terminate the connection, but still the server has some data to be transmitted to to the client. So it will not transmit the fin until it completes the data transmission phase. Now you can see from the picture, it is very clear. So the client is only, or one of the end. Like suppose the client cannot be ready to terminate the connection, but the server is ready. So both the similar procedure can also be applicable in a vice versa. So in TCP, one end can stop sending data while still receiving the data, but it will receive, so it needs to be responded, right? So now you can see the client is sending a finish command with the acknowledgement command, but server is not ready because it's have too much amount of data. So it just acknowledged the receipt of received fin, so it will only sending the acknowledgement, but the server has enough data to transmit. So now you can see data segment from server to client. So server will transmit the data, so it means data transfer phase is ready, it is continuously running. So the server is sending the data to the client, and it is the responsibility of the client to respond. So it means it will only transmit the acknowledgement, so acknowledgements from client to the server. So once the server is done with the data transfer, then only it will send the actual finish command. So it will set the fin command, then only this transmission was completed, and the client will acknowledge this receipt of this fin commands. Then this is the actual phase where the one of the transmission is blocked, is closed. However, another party is ready to transmit the data, is still sending the data. That's why it is called the half close. So this is called the half close. For more references, you can refer the chapter number 13, Data Communications and Networking, by the author Frozen. And you can refer the 5th edition, and also you can refer the 6th edition by the McGraw-Hill publication. So thank you.